All right, welcome back, guys. We're in section 7.5 today, which is DeMoivre's theorem. And this is used for finding the powers or roots of complex numbers in trig form. So remember, make sure you know the difference between trig form and standard form. And make sure you read the question and answer it in the form it's asking you to put it in. So here's DeMoivre's theorem for powers. If we want z to some power, then we do r to that power, and then we have the CIS of the power, whatever that is, times theta. So n is our power. And here's a short example here. We're not really going to go over that. We're going to go jump down here to our first problem, which is find 2 CIS 30 to the power of 5. And notice they want us to write the answer in standard form. So make sure you don't leave it in trig form. So z to the 5th would be equal to r to the 5th, so r is 2, times the CIS of 30 times 5. So 2 to the 5th is 32, and we get 32 CIS of 150. Now again, that's in trig form. We need to convert this to standard form, so we need to expand it out. So this is the cosine of 150 plus I times the sine of 150. And if we simplify those, the cosine of 150 is negative radical 3 over 2. And the sine of 150 is 1/2, so we get 1/2 I. And if we multiply all that times 32, that's going to simplify. It's going to give us negative 16 radical 3 plus 16I. So there's our standard form for z to the 5th. Okay. All right, so this one was nice because in the original problem, they gave us r and they gave us theta. We didn't have to calculate it. Our second one, we have 1 plus 1i to the 8th. Now, they might not put the 1 there. It might just be 1 plus I. Just remember, b in this case is 1. So we need to calculate r first. So r is equal to a squared plus b squared. So in this case, r is going to be equal to radical 2. To get theta, remember, we're going to do the inverse tangent of b over a. And if we do that, we get 45 degrees. So we've got our r, we've got our theta, we're doing the 8th power. So z to the 8th is equal to radical 2 to the 8th times the CIS of 8 times 40. Whoops, 8 times 45. So 2 to the 8th power is, or I'm sorry, radical 2 to the 8th power is 16. And 8 times 45 is 360 degrees. So really we can just write that as 0 degrees because it's the same thing. So we want it in standard form. So this is going to be equal to 16 times the cosine of 0 plus I times the sine of 0. And of course, we know the cosine of 0 is 1. We know the sine of 0 is 0. So if we simplify this all out, we are left with just 16. So that is the power rule for DeMoivre's theorem. The second part of this is the roots of a complex number. So the difference here is when we're finding roots, so notice here it says there are n distinct nth roots. So if we're finding the third root, there are 3 third roots. If we're finding the 5th root, there are 5 fifth roots. So your answer is going to be, actually, you're going to have multiple answers, and it'll be equal to the number that the root is that we're looking for. Okay? So here is the formula. And k in this case is going to be values starting at 0 going up to n minus 1. So for finding the third root, we would use 0, 1, and 2. For finding the fourth root, we would use 0, 1, 2, 3. And again, we will have that many answers. So first off here, we're finding 3 cube roots of 27. Well, 27 is not in standard form or any form, so we need to rewrite this. It's actually 27 plus 0i. So 27 is our real number. There's no imaginary, so it's 0i. So from that, we can find r. Again, that's going to be a squared plus b squared, which just gives us the square root of 27 squared, which is 27. And theta, so theta is equal to the inverse tangent of b over a. So theta is the inverse tangent of 0, which is 0 degrees. So we got our theta, we've got our r, we can plug it in. So first we're going to find w sub 0. W is the variable we're using for roots. So it's equal to r, which is 27 to the 1 over n is 3, times the CIS of theta, 0 degrees plus 360 times k, which in this case is 0, all divided by 3. So the third root of 27 is just 3, and 0 plus 36 times 0 is 0, divided by 3 is still 0, so we have 3 CIS of 0. Okay. So W sub 1 would be, again, 27 to the 1/3, CIS of 0 plus 360 times 1 divided by 3. So again, we get 3 CIS. 0 plus 360 times 1 is 360, divided by 3 is 120. Okay. And then the third one, same thing, we're going to do W sub 2. So 27 to the 1/3 power, CIS 0 plus 360 times 2 divided by 3, which gives us 3 CIS 240. So if you notice here, the only thing changing from each one of these is the degrees. And each time we change on this one, we're changing by 120 degrees. So the nice thing about these answers is especially when you're finding larger roots, like if we're doing the 5th root or the 7th root, where we're going to have 7 answers. Once you get the first 2 and you realize what the difference is in degrees, you don't need to do all of this work over here. You can just continue to add the degrees and add and add and add. And it's always going to be 360 divided by n that we're adding. So 360 divided by 3 is 120. Each time here we add 120. If we were doing the 5th root, for instance, which is what we're going to do next, you'll see how that works out. And we'll look at that. Okay, so let's take a look at the second one. So we've got the 5th root of, or the 5 5th roots of 1 plus I radical 3. So again, we need to find out what r is. So r is equal to the square root of a squared plus b squared, which is the square root of 4, which is 2. And theta is equal to the inverse tangent of b over a, which gives us, what does that give us? 60 degrees. Okay. So W sub 0 is going to be r, which is 2 to the 1/5 power, times the CIS of 60 plus 360 times 0, all over 5. So 2 to the 1/5 power is a crazy decimal, or it's a radical. We're just going to leave it as 2 to the 1/5. And then we have the CIS. So 60 plus 360 times 0 is just 60. Divided by 5 is 12 degrees. Okay. Now, when we do this the second time, it's the same thing. The only thing that changes is the value of K. This time it's 1. So we get 2 to the 1/5, CIS. So 360 plus 60 is 420. Divided by 5 is 84. Now, we need to do this 3 more times. We need W sub 2, W sub 3, W sub 4. But now that we've got these first two, we can easily see the difference between these two is 72 degrees, or 360 divided by 5. So instead of doing these calculations and writing it out every single time, we can just add 72 degrees. So the third root is going to be CIS of 84 plus 72, which is 156. Then we're going to have 2 to the 1/5 CIS and add 72 to that. We get 228. And then again, 2 to the 1/5 CIS, add 72 again, we get 300. So if you're doing several roots, once you get the first two, you can find the difference in degrees and then just continue adding that amount, and instead of doing all of this calculation over here. This is not needed. Okay. All right, so that's all of section 5. It's pretty short. Just make sure you are filling in the numbers right in the equation. Remember, if you are given r and theta, you can just plug them in. If you're not given r and theta and they give it to you in complex form, you need to find r and find theta before you can plug everything into the equations. And again, pay attention to whether they're asking for it in trig form or in standard form. Okay, we'll see you next time, which we will be doing section 8.5. That's the last section for the semester. And again, if you have any questions, office hours and questions on WebAssign, or send me an email. That's it. Talk to you guys later.